Today we're going to talk about measuring and constructing segments, section 1.2. Okay, so measuring and constructing segments. If you remember one of the first days we talked about geometry, I said geometry is kind of a very visual type math. If you struggle to visualize the math, one of the best things you can do is draw pictures to help you out. That is something that will help you out today. Okay, if you struggle to visualize it, don't be afraid to draw a segment out. Draw a picture out to help you solve problems. Okay, again, geometry is kind of more visual based. And if you can draw pictures so you can see it and be more hands-on, you'll have a lot more success a lot of times. First thing we're going to talk about today is some of the vocabulary. A coordinate. We all know what coordinates are. Coordinates, a number used to identify the location of a point. On a number line, one coordinate is used. On a coordinate plane, 2 coordinates are used. And in space, 3 coordinates are used. So we go from x to xy to xyz. Alright? In geometry, we focus on a lot of x, xy. Towards the end of geometry, we get to 3D space, and then we deal with xyz. But typically, we deal with x and xy. Distance. We're going to talk a lot about distance today. Distance is really important. Okay, distance is the absolute value of the difference of the coordinates of the points. Okay, here's something to think about when you measure distance. Let's say we take Valley, for instance. All right, if I want to measure the distance from Valley to Waterloo, approximately how many miles is that, kid? Valley to Waterloo. 4 miles. Okay, distance is 4 miles. Do you agree? Okay, let's say I take the distance now from Valley to Fremont. Spencer, how far is it from Valley to Fremont? 15 miles, right? Now, one of them I went kind of south, and one I went north. Does everybody agree? Does it matter in which direction I go? Distance is always measured what, though? Distance is always measured positively. Whenever I measure distance, distance is always a positive direction. Okay, it doesn't matter whether you go north, south, east, west, however you measure it, distance is always positive. If I go 10 miles east or if I go 10 miles west, it's still 10 miles either way I go. Okay, I'm never going to have a negative distance. That is important to know. Length. Length is the distance between the 2 points of a segment. Think about it. If I measure length, do we ever measure length in negatives? Like if I measure the length of this room, would I say it's negative 30 feet? No, length is distance. Distance is always going to be positive. Okay, so length is the distance between the 2 points of a segment. So again, length is going to be positive distance as well. Congruent segments. Congruent segments are 2 segments that have the same length. That is important. Congruent means same. Okay, congruent means they're the same. So congruent segments, 2 segments that have the same length. Again, we're going to talk a lot today about distance. Distance is always measured in a positive direction. Next 4. Between. Okay? What does between mean? In the middle. Okay? A lot of times they'll tell you somebody's like, oh, it's like when something's between 2 objects. Well, now you're using the word as it's, using the term as its definition. It doesn't work. A good definition here is, given 3 points A, B, and C, B is between A and C if and only if all 3 of the points lie on the same line and AB plus BC equals AC. Some people are like, what does that mean? That's math terms. Okay, here's what between means, and we're going to focus a lot on this today. If I have A and C, and B is between them, well, that means if AB is 2 and BC is 3, what's AC going to be? Anybody? What is it? 5. That's what between means. Okay, between means it takes a whole segment and it can cut up into 2 parts. It is between the segments. It's between the endpoints. Okay, that is what between means. Midpoint. The point that divides the segment into 2 congruent segments. So midpoint cuts it in what probably? Cuts it in half. And midpoint would cut it in half. Bisect. We use the term bisect a lot in chapter 1. We're going to use this one a lot. Bisect is to divide any 2 congruent parts. Okay, bisect cuts it in half. Okay, so bisect cuts in half. So it'd be like the same thing as finding the midpoint. It bisects it. It cuts it in half. And a segment bisector. What does segment mean? Segment is a what?
It's like a line.
It's like a line, right? Okay. What's a bisector mean? Okay, so a segment bisector is what probably? It's a segment cut in half. So if I have a line here, no, that's a bad line. So if I have a line, and I draw another line right there, that is a segment bisector. It cuts the line in half. Okay? Does anybody know what these little tick marks represent? I circled them down there. What do those little tick marks represent? Anybody? They're not numbers. They can, depending. This isn't a number line, though. In geometry terms, you will see this a lot. Those tick marks represent congruent segments. So if you see like two tick marks like that, that's saying those two segments are congruent. They're the same. It's the same thing if I do 2 and 2. Same thing. Those are congruent segments. So anytime you see those tick marks, it means the side lengths or those segments are congruent. That's important to note. Alright, so let's look at some of this base here. First thing I want to do is I want to find the distance between any 2 points. So the distance between any 2 points is the length of the segment that connects them. Now measure it. Now again, remember, anytime I measure distance is always what? Positive. Distance is always positive. So first thing it says, I want to find the distance from E to J. Okay, well what did they do? They did 7 minus 1. So opposite value of 7 minus 1 is 6. Opposite value of 6 is 6 centimeters. Let's try it the other way. What if I were to do 1 minus 7? Could I have done 1 minus 7? Yeah, because what's 1 minus 7? Opposite value of negative 6 is still... Doesn't matter. Either way you do it, you should always get a positive distance. Let's try number 1 here. I want to find EG. So EG there, I want to find the length. Claire, what would the length of EG be? That is 4 centimeters. How'd you find that? 5 minus 1 is a great work. Nice job. Number 2, I want to do EF. Okay, here's EF. How would I find the length of EF? Mr. Extra.
Take 1 minus 2.5 absolute value.
So you're saying 1 minus 2.5, okay. 1 minus 2.5 absolute value?
That's 0.5, or 1.5 absolute value, negative 1.5.
Absolute value, and that gets me?
1.5.
Nice job. Could I have done 2.5 minus 1 there? Same thing, right? Last one, FH. Anderson, how would I find the length of FH?
Well, you take 5 minus 2.5, which is...
Whoa, what? FH, not FG.
Oh. 5.5 minus 2.5.
Nice job. Okay, so there's finding the length of segments. And again, length is always what? Positive. Try these 3. Same idea. Sometimes students struggle on number 6. Think about it. Don't just write an answer down and get an answer. Think about number 6. Take a couple seconds to try these 3 on your own, though. Let's try number 4 here. I want to find the length of CD. Audrey, what's the length of CD? Okay, now, great point here. Do we know what the units are here technically? Okay, so instead of centimeters, what do we say? 2, just units. Okay? Yep, just 2 units. If it did give me centimeters, we'd say centimeters, but unless they give me something, we just say units, so 2 units. Number 5, I want to say the length of EC. What's the length of EC going to be, McCoolidge?
1.5.
What?
1.5.
1.5, he says. Okay, let's think about this. 1.5 units. Now, you agreed, right, that DC was 2? You agreed DC was 2. So DC right here, that's 2 units, right? Now, EC, is that shorter than DC? No, EC is not shorter. So would 1.5 make sense? Okay, that's one of those you gotta stop and think. Yeah, mathematically you might have got that, but you might have made a mistake because that doesn't make sense. What's the actual answer, Blake?
5.5.
Yeah, it's 5.5 units, or 5.5 units. How'd you do that, Blake?
Well, I just did like 3.5 to 0, and then 2.
So that's 3.5 right there, plus 2. That is a great way to do that problem. All right, last one here. This is the one most people mistake on. 6. Becca, what do you got for an answer? You say 0.5 units? You got it correct. Nice job. What do most people do on this problem? Does anybody know?
Probably put like 1.5 or something.
Somebody earlier today put 7.5 because they took 4 and 3.5 and added them together. So they got 7.5. I got that one today. Another common answer is a lot of people put negative 0.5 here because they see it on the negative side. They're like, oh, it's negative 0.5. But why can it not be negative? Because it's length, it's distance. Distance is always measured positive. So make sure you recognize that. Nice job. All right, next. We're going to talk about some segment lengths here now. This is something where it will help you if you draw something out. If you're not a visual person, it will help you to draw it out. Okay, number 7 says H is between X, Y. Can everybody imagine what that means? H is between X, Y. Well, that means I have a segment here. There's X, there's Y, and H is somewhere right there. That's what that means. It says H is between X, Y. Okay, so I have X, Y, H is somewhere cut up in between there. I know that HX is 3.9. I know that HY is 6.2. I want to find XY. Well, how can I find XY here? Parker, what do you think I might be able to do? Yeah, right? If I have 2-part segments and I want the whole segment, what am I going to do, Parker? Yeah, I'm going to add them together. So I would take 3.9 plus 6.2 and I get 10.1 units. Okay? Again, what do students struggle with here sometimes? They draw a picture wrong or they don't visualize it correctly. Okay? Again, if you draw it out, you can visually see, well, if I have 2-part segments here, add them together. That's going to give me the whole segment. It makes sense. Next one here. It says B is between A and C. So I have a segment here. There's A, there's C, and B's like right there. Okay, it says AC is 14. Okay, so AC is 14. It says BC is 11.4. I want to find AB. Uh-oh. It's not like number 7. This is a different problem. What am I supposed I'm going to do here, Mr. Wilson?
I think you'd subtract.
Why would I subtract this time?
Well, because you have a full segment and then you have part segment, so you got to subtract.
Correct. Yeah, if I have the full segment and a part and I need to find the other part, what am I going to do? I'm going to subtract. So I would say 14 minus 11.4, and I get what, Mr. Wilson? Bless you.
2.6.
2.6 units. Everybody does great on 7 and 8. Oh, boy. And then we get to this problem like number 9. M is between N and O. Okay? I'm going to take the editor off here if you guys don't mind, so you guys can see at the bottom. Okay? M is between N and O. It wants me to find NO. Okay? I have variables now. Do we all agree 2 parts add up to get a whole? Does everybody agree with that? Okay. I'm going to put the editor back on here. Does everybody agree I have a 17 here as a part and 3x minus 5 as a part, right? If I add those up, what should I get? Should I get the whole? Yeah. So I'm going to say 17 plus 3x minus 5. Oh, I messed up. Shoot over a little bit. 17 plus 3x minus 5 equals, what's the whole segment length? I set that equal to 5x plus 2. Now, it's just like one of the problems out of our warm-up. Can I solve for x algebraically now? Yeah. Combine like terms. 17 minus 5 is. So I have 12 plus 3x equals 5x plus 2. Subtract 3x over. I get 12 equals 2x plus 2. Subtract the 2. 10 equals 2x. X has to equal what? Is that my answer? No. Why is that not my answer? It says it wants me to find NO. So I take the x equals 5 and I plug it in where NO is. So I plug it in right down here. What's 5 times 5? Plus 2. I get a length of 27 now. Okay, recognize that is a more difficult problem. Why? Because I actually have to set something up to solve. Okay, and again, you're still using the same idea, 2 parts equal a whole, but you have to solve for x here. Alright? Using those same ideas, try these 3. Take a couple seconds and try these 3. 10 and 11 are just like the first 2 we did. 12 is just like the last one. Set it up, solve for x. Take a couple seconds, try these on your own. Alright, so number 10. xy is 25, xh is 13. What's yh gonna be, Jeremiah? It is not 38. Beast, what is it actually? It is 12 units. Why is that, Jake? Because I subtract, yeah. H is between x, y. Here's x, there's y. H is somewhere in the middle here. XY is 25, so I have the whole segment. XH is 13. Well, I have the whole in the part. I want to find the other part. That has to be 12. Again, draw the diagram, help yourself visualize. 11. Simeon, what'd you get? That is correct. Nice job. So I have VW here. T somewhere in the middle. VW is 9.3. TV is 4.5. Subtract them and you get 4.8 units. Alright, last but not least, number 12. How would you set the equation up? Chris, how would you set it up first?
I'll put 13 plus 3x minus 1 equals 6x.
So 13 plus 3x minus 1 equals 6x. I agree with that. Great. When you did that, you get x equals what, sir?
X equals 4.
When we do that, we get x equals 4. Is that my answer?
No.
I want to plug it in for what this time, though? I want to plug it in for DE. So I take that, plug it in here, and I get what, Chris? I get 11. Nice job. If you got an answer of 24, you plugged it into the wrong segment length. Okay, good work. Last thing we're going to do today is we're going to talk about midpoints. Who remembers what a midpoint does? Cuts it in half. So let's think here. The midpoint of a segment separates the segment into 2 congruent segments. In the figure, P is the midpoint of NQ. So that means that PQ is going to be the same as what? Well, PQ is the same as NP. How would I find the value of X here then? If these 2 segments are the same, what do I know about their 2 expressions then, Callie? I would set them equal to each other. So 3x equals 2x plus 4. Can I solve for x now? Yeah, I'd subtract 2x. X equals 4. Now, can I find all of my lengths of the... Yep, what's NP going to be? What's PQ going to be? And what's NQ going to be? 12, 12, and 24. Our midpoint's probably a little bit easier. Yeah, actually, you can just set them equal to each other, really. Alright, take a couple seconds to try these 3. The first one, just number. Just number-based, pretty straightforward. 17 and 18 are just like the last one we did. Take a couple seconds to try these 3 on your own, though. Alright, let's go through these here. So 16. A is the midpoint of BC. What does it mean to be a midpoint again? Becca, midpoint cuts it in half. So if 1/2 of it's 5, what's the other half of it, Becca? 5 as well. 17. X is the midpoint of YZ. If XY is 5X and XZ is 3X plus 4, find YZ. First, I need to find X. Colon, what is X going to get me? On 17. X equals 2. And then I would plug that in, and YZ comes out to be 10. Nice job. And lastly, 18. Same thing. D is the midpoint of EF. ED is 4X plus 6. DF is 7X minus 9. I need to find EF. Spencer, what does X get me first? Are you still working? Katie, do you know what X is? Claire? Yeah, what's X equal? X equals 5. You plug it back in, what's EF going to get me? EF is 52. Why is it not 26? Because I wanted the whole segment, right? So here you'd have to plug it in almost both of them, or just to plug it into 1 multiplied by 2. But yeah, you get 52 here. Nice job. Here's your assignment.